Hello and welcome. Today, we're going to go on an incredible journey. It's one we all take, pretty much every single day, but we almost never stop to think about it. We're going to follow one bite of food from start to finish. So let's get started. So, picture this. You take that first bite of something you love, maybe a crunchy apple or a slice of pizza. It tastes great, but what's the actual plan here? How does your body turn that food into fuel, into energy, into, well, you? That's the big question we're tackling today. The whole amazing process is called digestion, and really, it's all about transformation. See, your food is made of these big, complex things like starches and proteins, but your body can't use them like that. Digestion is the genius system for breaking all of that down into tiny, simple parts that your body can actually put to work. So here's our roadmap for the trip. We'll start with why we need food in the first place, then follow it from the mouth, down into the stomach, and through all those winding intestines. We'll even take a quick look at how other creatures do it before we wrap up with the 5 basic rules that apply to everyone. Okay, first things first, why even bother eating? Well, just like a car needs gas, every living thing, from the tiniest bacteria all the way up to us, needs fuel. We need food to grow, to repair ourselves, and to get the energy to do literally everything, from running around to just thinking. And this is the map of our entire journey. This whole pathway, from top to bottom, has a name, the alimentary canal. I know, it looks like a jumbled mess, but believe it or not, it's one long, continuous, and highly organized tube. Let's start right at the beginning. Our journey kicks off in what scientists call the buccal cavity, which is just a very fancy way of saying the mouth. But it is so much more than just an entrance. Think of it as a high-tech food processing station where the first really crucial steps get underway. A ton happens in here, and it happens fast. First, you've got ingestion. That's just taking the food in. Right away, your teeth get to work, grinding and tearing everything into smaller bits. That's mechanical breakdown. At the exact same time, saliva floods in and starts the chemical breakdown. And the tongue? It's the master mixer, making sure everything is coated before pushing it on to the next stage. And this little experiment shows you just how powerful saliva is. Look at the left tube. You mix boiled rice with iodine, and it turns dark blue. That's the classic test for starch. But on the right, you do the same thing with rice that's been chewed, and nothing happens. Why? Because the saliva has already broken down all that complex starch into simple sugars. That's chemical digestion in action. So once you swallow, the food doesn't just fall down into your stomach like a rock. No, it gets actively pushed down the food pipe, or the esophagus, by these incredible wave-like muscle contractions. This system is so good, it would work even if you were hanging upside down. Though, maybe don't try that right after dinner. Our next big stop is the widest part of the whole canal, the stomach. You can think of this J-shaped, thick-walled bag as being like a powerful cement mixer, just churning and combining everything that comes down. The stomach has a pretty amazing set of tools. First, it secretes mucus to line its own walls. This is super important because it protects the stomach from the powerful acid it makes. Then, there's the hydrochloric acid itself, which kills off most of the nasty bacteria you might have swallowed. And finally, special digestive juices kick in to start the really tough job of breaking down proteins. But how did we figure all this out? For the longest time, what happened inside the stomach was a total black box. That is, until a very strange and unfortunate accident gave science a literal window into the digestive process. This is the incredible story of Alexis St. Martin. Back in 1822, he had an accident with a shotgun that left a permanent hole right into his stomach. His doctor, William Beaumont, saw this as an unbelievable scientific opportunity. Through that hole, he could literally watch the stomach churn food and see the digestive fluids it secreted. It was a revolutionary discovery, all because of a completely bizarre accident. All right, leaving the stomach's acid pit, our now partially digested food moves into the longest, most coiled part of the whole trip, the small intestine. This is where the main event, the real heavy lifting of digestion and absorption, actually happens. So, just how long are we talking? Take a look at this number. That's right, 7.5 meters. To give you some perspective, that is way taller than an adult giraffe. So the obvious question is, how on earth does that fit inside of you? The answer is both simple and kind of amazing. It's just incredibly tightly coiled up, just like we saw in that first map. Nature is a master of efficient packing. The small intestine is basically absorption headquarters. It gets help from its neighbors. The liver sends in bile to handle fats, and the pancreas chips in with juices for just about everything else. The intestine's own walls then secrete a final juice to finish the job. All those simple nutrients are then absorbed through these millions of tiny finger-like walls called villi. Together, they create a massive surface area, about the size of a tennis court, all to make sure your body soaks up every last bit of goodness. Anything that's left over and undigested moves on to the large intestine. Its main role here is really conservation. It's much wider and shorter, and its whole purpose is to absorb most of the remaining water and some salts before what's left is finally removed from the body. So that's the human journey. But our way of doing things is just one of many, many solutions that nature has come up with. Let's take a quick look at some other incredible digestive strategies out there in the animal world. Take a cow, for instance. Grass is full of this really tough stuff called cellulose that we humans just can't digest. But cows have a special part of their stomach called the rumen, which is basically a giant fermentation vat filled with helpful bacteria. They swallow the grass, let it sit in the rumen, and then bring it back up to chew on it some more. It's a brilliant solution for a really tough diet. And if you thought that was strange, get a load of the starfish. This might be one of the weirdest ways of eating on the planet. It finds something in a hard shell, pries it open, and then it pushes its own stomach out of its body and into the shell. It digests its meal externally, and when it's done, it just slurps its stomach back in. Absolutely wild. Now let's go even simpler. This is the single-celled amoeba. It doesn't have a mouth or a stomach or anything like that. When it finds a food particle, it just extends these false feet to flow around and completely engulf it. The food gets trapped in a little bubble, and the amoeba just injects digestive juices right in. It's a whole digestive system inside a single cell. So, from our complex system to a starfish to a single-celled amoeba, it seems like everyone is doing things completely differently. But what if I told you that all of them, every single one, is just following the same 5 basic rules? And here they are. These are the 5 universal steps. You have to get food in, ingestion. You have to break it down, digestion. You have to soak up the good stuff, absorption. Then your body has to use those nutrients, assimilation. And finally, you get rid of the waste, egestion. A cow chewing its cud, a starfish with its stomach out, and you eating a sandwich, we're all playing by the same rule book.